Hello everyone, this is Mukundan Raghavan, and this video we are going to clearly understand the cosine similarity in case of vector database search. So let's start from the very basics and try to understand the scenario. From that scenario, we will try to understand where the cosine similarity was used. Imagine the first one, you have a lot of images and these images will be converted into the vector, and second step, it will be stored into the vector database. Now you want to upload a new image. Obviously, since it's a vector database, we need to convert even the new image as a vector in order to search further. Now you are converting the new image to vector. Now you will be taking this new vector and comparing with all the vectors that are in vector database. Now, how do you compare? Because it's not an image, no. It's not a simple data, no. Then it is a vector. So in order to compare the vector with vector, you will use the cosine similarity. First of all, you will calculate the cosine similarity, then you will identify the most similar image. Now the question is how the cosine similarity works and what are the output. Let's try to understand. Before going to the cosine similarity, here magnitude does not matter. Maybe if you are not from the technical background, let's try to understand the simple illustration. Imagine you have a database which has ice cream and pizza. Now, vanilla ice cream and chocolate ice cream both are similar, whereas veg pizza is not similar. Here, no matter whether it's a vanilla ice cream or chocolate ice cream, they are similar in nature because it's the ice cream. At the same time, let's imagine one person took three vanilla ice cream, another person took only one ice cream. Still, they are similar in nature because it does not matter how many ice cream they took, they are interested in ice cream. Similar way, cosine similarity also looks about the direction of the vector, not its magnitude. In previous video, we have seen what is vector, how it looks like. And most of the time, we will be comparing the vector in 2 dimension or 3 dimension because that is the visual limitation we have. Let's understand further. Before going to further slides, the main point here is cosine similarity focus on the angle between two vectors, not their length. Now let's understand further. Imagine if two vectors are in same length, since magnitude does not matter, and if I keep the torchlight over the one vector, the shadow of the first vector falls on second vector fully. That means that both are traveling parallelly and both are having angle difference as 0. In that case, the cosine value will be 1. Even if you go to the table mathematically, cosine 0 is 1. Imagine the second scenario. One vector is 90 degrees perpendicular to other. Then if I put the same x-axis torchlight, the shadow of the first vector will be not at all falling into the second vector. So that's the reason if the angle between two vector is 90, then you will not have any similarity. It will be no similarity. Even if you go to the cos table, cos 90 will be 0. The third scenario, again, it is -1, where one vector is totally traveling opposite direction of the other vector. So we can clearly understand it is totally dissimilar vector or totally opposite vector. In that case, the degree will be 180 degree and the cosine value will be -1. So by this understanding, by this illustration, we can clearly understand if there are two vectors, if the angle between these two vectors is 0 degrees, that means it's completely similar and the cosine value will be 1. If the angle between two vectors are 90 degree and the cosine value will be 0, no similarity. Whereas if the angle between two vectors are 180 degree, then the cosine value will be -1, completely dissimilar. If the angle between 0 and 90 degree, you will have value between 0 and 1, which means that which are closer to similar but not actually similar. The more the value goes to the 1, that means that you will be having very nearby similar. If it is reaching 0 or nearby 0, it is very close to the no similarity. Now we have seen the angle between these two vectors and how it works. The illustrations were good. But however, we have the vectors. Vectors means that you have seen already, vectors will have multi-dimensions data. Since we discussed, we could not see or visualize the multi-dimension. Let's take it as a 2 dimension. Here you can see two data points. One is 3, 4, another one is 4, 3. Now, if you see what is the angle between this, we are not going to just measure the angle between these two vectors by directly having the degree. We are going to use the dot product. If you don't want to get into the dot product, it's a simple value, scalar value output, which will give the same cosine value. Here, we are not going to just punch in the degree. We are just giving the vector values. For simplicity, we have given the 2-dimension vector. The dot product of A dot B would be 3 into 4 and 4 into 3 equal to 12 plus 12. 24, and magnitude of the A would be just square that value and take the root. Again, these values also fine. Now, if you just punch in all the values into the formula, you will get 0.96. So that means it is very closer to 1. That means it is similar in nature. So that's the understanding we have got from this video. So just to summarize everything, just we have seen the flow, how the image can be converted into vector, and vector versus vector will be comparison happening using the cosine similarity. Before proceeding, we have understood magnitude does not matter, because if you take one ice cream or five ice cream and you compare with other person takes only one ice cream, both are similar nature because you are interested in the ice cream, not the count of that. And second one, since the magnitude does not matter, every vector, a specific vector will be converted into the same unit. And if you put the torch from the x-axis top, then if the shadow fully falls on the second vector, that means that both are traveling the same direction at the same time. It has 0 degree between those. And same 90 degree. For 90 degree, the shadow of the first vector will be following on the second vector would be 0. So that's the reason these are no similarity. If it is 180 degree, even the shadow will not be following, but the direction of one vector is totally opposite to the other direction. The value will be -1 and it will be traveling into the opposite direction. By this, we concluded there are possible values could be 0, 90, 180, or in between those. 0 means completely similar. The value of the cosine would be 1. 90 means no similarity. The value of the cosine will be 0. 180 means completely dissimilar opposite direction. The value would be -1. So your cosine value will be ranging between -1 to +1. And we have seen vectors are not just having some arrows or some angle measurement. We have the data points. For simplicity, we have seen basic two vectors, two-dimension vectors, and we will use the formula that has been shown here. A dot B or A dot product of B, then magnitude of A into magnitude of B. The simple formula will be following like this, and you will get the scalar value. You will not get any degree, you will get the scalar value. 0.96, as we discussed, it's close to the 1. That means that it is more similar. So these are the simple understanding about the cosine similarity. If you want more understanding about the cosine and other things, you can just refer again to the mathematical concepts. But for vector database, this is enough. And this is all about this video, and always be a rainbow in others' cloud.